Hello, fam. Welcome back to my YouTube channel, The Beauty in Mathematics and Physics. Today we have an interesting radical to rationalize, a very peculiar problem, a quite challenging one, but the mandate is to make it simple to understand. Now we are to rationalize this expression we are seeing here, 1 upon 2 raised to the power of 5 on 6 plus 2 to the power of 1 on half plus 2 to the power of 1 on 3 then plus 1. It's actually an internal Olympics competition of Saginaw Valley State University in America. Now let's get at the solution. Now if you look at the denominator here, it's a rather complex radical expression. So what we shall do is to factorize it. So I'm going to have 2 to the power of 5 on 6 plus 2 to the power of half plus 2 to the power of 1/3 plus 1. Now the first thing that we shall do is to make these fractions to have the same denominator. So it means that I have to multiply up down here by 3 and multiply up down here by 2. So that's going to give me 2 raised to the power of 5 on 6 plus 2. Here I will multiply both numerator and denominator by 3. That becomes 3 upon 6. Here I will multiply both numerator and denominator by 2. I'm having 2 to the power of 6 plus 1. That's what we have. Now, at this level, we shall do what we call factorization by grouping. I will group this pair and I will group this pair. And if you look at this pair, 2 to the power of 3 upon 6 is actually the HCF of this and this. So I will factor it out. The next thing I shall do, I will use 2 to the power of 3 upon 6 to divide 2 to the power of 5 upon 6. Now, in exponents, once we are dividing two base numbers, we are told to subtract the exponents. So if I remove 3 on 6 from 5 on 6, I'll be having 2 on 6 left. Now, if I use this to divide this, that's going to give me 1 in one parenthesis. As you can see here, only 1 is common. I'll write 1 out, then I'll write to the power of 2 upon 6 plus 1. So we are going to have. Now, when we are factorizing algebraic, expression, what we do, we pick the outside factors, the same we are going to do here. I'll write 2 to the power of 3 on 6 plus 1 in one parenthesis, then 2 to the power of 2 upon 6 plus 1 in another parenthesis. So this radical expression here that has very complex exponents, these are the factors. So these are the surds which are rationalized. Meanwhile, before we rationalize or attempt to, I want to reduce the fraction here. This is going to be 2 to the power of half plus 1. Here I'm going to have 2 to the power of 1/3 plus 1. So now what I shall do next, I shall use the difference of two squares and the sum of two cubes. Now write using difference of two squares for the first factor. For the first factor, that's going to be 2 to the power of half plus 1 multiply to the power of half minus 1. This will be equal to the power of half all squared minus 1 all squared. Now, what I've done here is using this formula a squared minus b squared equal to a plus b into a minus b. We are very familiar with this formula. This is the formula for difference of two squares. I want to literally repeat what I did here. for the sake of our audience. If I were to write this first factor in the radical we know, that would have been root 2 plus 1. Then the conjugate of this is going to be root 2 minus 1. And if I multiply a surd with its conjugate, like the one we are having here, we are going to be having difference of 2 squares. So this is going to be root 2 squared minus 1 squared. Now, if you watch very carefully, root 2 squared means root 2 multiply root 2. So when like surds multiply each other, actually pair, the radical sign will disappear. So if I have root 2 multiply root 2, this will give me 2. If I have root 3 multiply root 3, this will give me 3. So this is very easy to comprehend. So at the end of the day, like I said, this is going to give us 2 minus 1, which is equal to 1. I'll keep that in mind. Then for the cubic surd, I shall not bother to write this in a cube root because it will confuse us. I shall go to sum of two cubes. From the sum of two cubes, I have that if I have a to the power of 3 plus b to the power of 3, I'll pick one a and one b and add it. Under parentheses, pick this a here and square it. I'll take the subtraction, pick one a and one b, multiply it, then pick one b and square it. So this is the sum of two cubes. For the sake of this problem, I shall turn it. So this is the same thing as saying a plus b in parentheses, a square minus ab plus b square in parentheses equal to a to the power of 3 plus b to the power of 3. Then I will take the second factor here to the power of 1 on 3 plus 1. So this implies that 2 to the power of 1 on 3 plus 1, we are now going to get the conjugate, a very special kind of problem. So the conjugate is going to be a square. Here a is 2 to the power of 1/3, b is equal to 1. So a squared becomes 2 to the power of 1 on 3 squared. If I use the power rule here, it becomes 2 on 3. If I use the product rule of indices, this becomes 2 to the power of 1 on 3 times 2 to the power of 1 on 3. So we add the powers here, that becomes 1 on 3 plus 1 on 3, which is 2 on 3. So here I'm going to be having 2 to the power of 2 on 3. I'll pick a. A is 2 to the power of 1 on 3. Then I'll multiply it by 1. There will be no change. 2 to the power of 1 on 3. I take b, which is 1. I square it. That will also give me a 1. So for a fact, I cannot say that the sum of two cubes, has enabled me to know that the conjugate of this surd or radical 2 to the power of 1 upon 3 plus 1 is actually what I have in these parentheses. 2 to the power of 2/3 minus 2 to the power of 1/3 plus 1. So far so good. We have done well. We have developed this problem and simplify it. Now the next thing I shall do is to rationalize the entire, surd. Now mind you, I want to retain this. I will take this off. When we simplify this surd, we have something like this. Two to the power of half plus 1 as a factor, 2 to the power of 1/3 plus 1 as a factor. So this is the surd we are going to rationalize. It means that I have to multiply this fraction, which has this radical on the denominator, by the conjugate of these two radicals I have here. So this is going to give me something very interesting. This is going to be equal to 1 upon 2 to the power of 1 on 2 plus 1. Let me draw this neatly because it's going to be a very big expression. To the power of 1 on 3 plus 1, under parentheses. I will multiply this by the conjugate of this, which is root 2 minus 1. Root 2 minus 1. Put that in parentheses. Then I will multiply it again with the conjugate of this radical here, which is this expression. So I will write to the power of 2/3 minus to the power of 1/3 plus 1. Everything divided by the same conjugate. Okay, there's no need to actually put a square root sign there. I think there's a need to change that. So no need to put a square root sign here. I have to write this in exponents for simplicity. So to the power of half. So we should know that this is actually the same thing as root 2 minus 1. Now, if you look at what we see here, this and this, we already have the answer here, which is difference of 2 square 1. Then, if I multiply this and this, the answer is supposed to give me something very simple. I will take 2 to the power of 1/3 and cube it. That's going to be 2 to the power of 1/3 raised to the power of 3. That will give me 2 to the power of 1/3 times 3, which is 2. Now I will take 1 and cube it. That will be 1. So here I'm actually having 3. I will bring this information to this last lap. Now I'm only going to retain the numerator. To the power of 2/3 minus to the power of 1/3 plus 1. Now, like I said, if you multiply this with the conjugate, you are going to have 1. If you multiply this guy with the conjugate like you have here, you have 3. So everything divided by 3. So this is the solution to this problem. If I were to write this in a more refined expression, I think I can put that one here. So I will write the answer as 1 upon 3, the power of half, minus 1 to the power of 2/3 minus to the power of 1/3 plus 1. So this is the solution to this problem. Now, as you can see, it's actually a challenging problem, but we have simplified it to the best of our ability, and I guess you understand. Now, continue to like, share, watch our videos. Thanks and see you next time. Bye-bye.